right. Hello, everybody, and welcome back to the stream. Oops. All right. Windows already freaking out on me. Good start. Okay, so let me just go ahead here and make sure everybody is notified that the stream is going. Should be good. Okay, so welcome everybody back to the stream. Today we're having a second stream for this week because I didn't quite accomplish everything that I wanted to, at least for this week. So we're doing another night. And in case any of you are new to the stream, in this stream we are developing a game engine from scratch using C and Vulkan. And we are aiming to do most, if not all of it, on stream. There are a couple of parts that I have done off stream up till now. This initially started as a YouTube series, but I've decided to go live with it instead. So up to this point, we do have a functioning renderer, albeit a basic one. We've got a number of systems set up, including things like an event system and hot reloading of our game code, which is something we actually just got working, and a number of other systems that we've put into play. And now we are looking at creating, I guess not really another system, but adding another feature to the engine. So hey Mighty, welcome to the stream. So the way that the stream works is I'm basically going to be explaining my thought processes as we go through here, and it's designed to be an interactive stream. So if you guys have any questions or comments along the way, please feel free to pop them into the chat. I will be keeping an eye on that, and I will answer anything to the best of my ability. All right, before we jump into the code real quick, I want to take a quick second and thank our supporters of the channel. And these are folks that have pledged on Patreon or have joined YouTube memberships. And they are here. So they have graciously supported the channel financially. So our partners are the highest tier of support. That is Caden Parker, A.R. Slia, Gerboles Inc., Super Awesome, and Wen Chang. And we also have support from all these other fine folks that are listed down here in the supporters section. And so, of course, financially is not the only way to support the channel. One of the best ways to support the channel, of course, is by joining into the stream, interacting with it here, spreading the word, and helping get the word out, because this is designed to be a educational stream, and I'm hoping to reach as many people as possible to help people understand how game engines work and go over how you might actually implement one from scratch. Okay, so with all of that out of the way, I think we can actually go ahead and jump into our discussion. So I've gone ahead and done a little bit of brainstorming about this. And let me just pull up my notes here. So here we go. So I'll just drag this down here real quick. And so I've created a basic outline of some of the things that we are going to kind of take a look at, think about, and go ahead and start implementing. So ultimately, what our next big goal is to implement scenes in the engine. And a scene is basically a collection of a bunch of different types of objects that make up the game world. And the scene sort of manages all of these things collectively and helps batch things up and is responsible for knowing where things are, how they interact with each other, as well as giving us a way to sort of manage all of those things as a whole. And so it's a little bit more than that, but that's kind of a simplified explanation. So there are a couple prerequisites that we're going to need to do before we should really jump into scenes. And that is these couple of items up here. So we need to confirm that mesh unloading works. Let's see. Norland lurking while raiding. Thank you for the support. I appreciate that. So there are a couple things here that we need to make sure that works. One of those things is mesh unloading, because with a scene, you should be able to load and unload everything all at once as a scene, right? And so in order to facilitate that, we have to have one way to actually, or a way to actually be able to unload meshes. And of course, textures should be automatic because we've got our texture system that we put in very early in the series. And those texture references, I'm pretty confident, are pretty well versed in unloading themselves when they're not registered anymore. So I'm fairly confident that system works. The other thing is we need to turn lights into actual objects in the world. Right now, our lighting is completely hard-coded into our shader. So we actually need to go about creating these objects in code and preparing them to actually be added to a scene, loaded, unloaded, although there's not a whole lot that needs to be done for lights because they're mostly just data. There is a little bit of work that needs to be done there. Likewise, we need to turn our skybox into an actual object in the world, and that's probably 80 to 90% done. There's just a few things I want to check on with that. And then once we've done those things, I think that's probably enough to start sort of toying around with this a little bit. And so what we're going to do is we are going to define a generic scene interface. And this is how I'm kind of thinking about doing it initially. This plan may change as the engine evolves, but this is the way I'm thinking of going about it for right now. The reason for that is because there are going to be at least two different types of scenes. So skipping ahead for a second here, we are going to have what I'm going to call a non-ECS, or maybe a basic scene, something like that, which is basically going to use a collection of known types. And non-ECS should kind of give it away that we are eventually going to have an ECS. But this particular type of scene is going to be set up to not work with an ECS, because not every project needs the complexity of an ECS. So we are not going to require that in our engine to actually work. We are going to first build a scene without an ECS. And then what we're going to do is we're going to create a ECS scene. And that's going to use entities and components. For you, those of you who don't know what an ECS is, it is an entity component system. So it uses entities which contain components that use the known types under the hood. So we'll kind of jump back to that, but these are the two types of scenes, at least for now, that we're going to create. And so both of those will implement a generic scene interface. And I say interface because C doesn't really have interfaces, but we've sort of dealt with this before with our renderer plugin. So basically, the reason for this is we do not want the engine to know or care about which type of interface or which type of scene we're using. We don't want the engine, specifically the renderer and other stuff like that, we don't want it to know or care about, are we using an ECS, are we not using an ECS, what's our scene hierarchy, all that crap. It doesn't care. It doesn't care as far as the render is concerned. It doesn't matter. And so this is our way of sort of decoupling that, right? And so our generic scene interface is going to provide several functions. So we're going to have a create, which essentially creates just the scene sort of structure itself. And then potentially with configuration. So we can stand up a scene in code, or we're going to be able to load some sort of configuration file for that scene. And that will obviously have a file format of its own. We've written several of those here in the engine. So with a create, we have a destroy, which if the particular scene is loaded, it will release all resources held after that. So this is basically just to make sure that we don't leak any memory, right? And then we're going to have an initialize. An initialize reads the configuration that is passed into create, potentially. If it has one of those, it'll read it and then set up an unloaded hierarchy. So we're going to have a hierarchy. You can think of it as a scene graph if you want, and I'll get into a little bit what that's going to look like here in a minute. But this basically just reads and sets up that hierarchy, but it doesn't actually load any assets. So it doesn't load any meshes, any textures, or any effects or sound effects or any of that kind of stuff, right? All this does is say, okay, we have this configuration that needs these things, and we scaffold basically an object tree, and that is what gets set up in this step, okay? And then we have a load function, which actually performs resource acquisition of all objects in the hierarchy, right? So everything that was created in initialize, when we call load, each one of those things will eventually, or will have its own load method where it goes in and loads geometry or acquires textures, things like that. And that is where that is actually performed. Of course, since we have a load, we have an unload, which undoes all of that. And then we have an update, which updates all the active objects in the hierarchy. So it makes any updates that the individual objects might require. Like animated objects are going to require constant update calls. Maybe a water block might require some calls to texture mapping updates and waves, things like that. And then we're going to have some method to obtain renderable data. So something like our geometry render data, right? And this is going to be done in a scene agnostic way, right? So the scene is going to manage how it gathers this data internally. And that data will then be handed off to a render packet, sort of what we're doing manually right now in our game code. The scene is going to handle that for us. And update and this method, which I haven't thought of a name of yet, are only going to execute if the scene is actually enabled / active. So a couple other notes here. The scene will have a scene transform, so it will actually have a transform of its own. And the reason for this is because we are going to allow multiple scenes to be loaded at once. Why would we ever want to do that, you might ask? Well, we can have scenes that are parented to one another as a form of grouping objects. We can also use scenes to transition from one scene to another. So a common thing that you'll see in a lot of games is you'll sort of wind your way through a cavern, and then it'll go through this tight little spot on the where the camera angle is real tight, and you'll have to sort of go between rocks or something, or maybe some pallets or boxes or something, and you'll walk through that kind of slow. And what that's actually doing is there is another scene on the side of that that is loading as you're actually passing through that. So it's a common technique that's actually used to actually load from one scene to the next. And the way that I'm thinking about doing it is you basically wind up with three particular scenes, right? So you'd have a scene for like room A that would be here, and then you have the transition scene here, and then you have your room B over here. And as you traverse from A into that transition scene in the middle, A would actually unload and B would start loading. And then once you're able to go all the way through that, B should be loaded and you should be good. And so that is what we're going to allow for that. Scenes can be enabled and disabled. So if we don't want to unload it, we can simply disable it, and that turns off all updates, all rendering, just with the flip of a single flag. Scenes should have a general state that kind of follows this a little bit. So we'll have an uninitialized, which means it's been created, but nothing more. The initialized means the configuration has been parsed. Unloaded, hierarchy has been set up. Loading is in the process of loading hierarchy. So the reason that we have this initialize and load separate is because once initialization is complete, we have a total number of objects that need to be loaded. And we can surmise from that how far into loading we are by taking account of loaded objects versus objects that are still loading, and that can give us a percentage, which we can then use for a loading bar or something like that. So we have a loading state. We have a loaded, so that means that everything's ready to go. We are ready to actually interact with the world. And that's where we're obviously going to be spending the most time. And then we have an unloading, which means that we're unloading everything and it is not ready to play. I'm not 100% sure that we're going to need that individual state, but I figure it's better to add it than not have it. And then, of course, unloaded, which means that the scene is unloaded and ready to be destroyed, right? And this flag is basically what will determine whether destroy actually performs an unload or not, right? So whenever we call destroy, technically speaking, if we're in either one of these two states, we would not call unload. But if we're just unloaded and we call destroy, then we're going to say, okay, so we'll start unloading, and then we'll flip to this, right? So I hope that makes sense so far. Okay, so that is the generic scene interface that we're going for. This is everything I could think of sort of off the top of my head. Of course, this is going to expand with lots of other things that we are going to be adding, but for now, that's basically it. And then we're going to create the non-ECS scene, so I haven't really come up with a name for this yet. I'm thinking like simple scene or basic scene, something like that. It's going to be a very bare bones sort of let's get it working and running. And then we can sort of extend it beyond that. So again, it's going to use the generic scene interface. It's going to add and remove the renderable types directly, right? So we'll have functions like add mesh, add skybox, add light, things like that. We'll also have remove mesh, remove skybox, remove light, etc. Right? These will be explicitly using those types. We will also, in the add methods, I'm thinking right now we'll return what I'm going to call a sim object ID. So a sim object is really nothing more than an index into an array. And what I'm thinking for this is a sim object will have a renderable, potentially, and a transform, potentially. And so the sim object ID will be unique across the board. And every time you add one of these, it'll just return that ID. And that ID will give you an index to actually reference that by if you wanted to parent it or something like that, which is actually the next thing I mentioned here. So sim object ID may be provided as a parent to the add methods. So that's another thing I'm thinking of. So if we've already got a sim object ID and we want to add children to that, this is how we're going to do it. If that is not found, like it's an invalid ID or something, a new sim object is created without a parent and a warning should be thrown. Pointers to renderables are stored in internal lists for each type. So you pass a pointer here, it just keeps a copy of that pointer internally. The scene is not going to be directly, well, I haven't really decided yet if the scene is going to own that, right? I think it kind of makes sense for the scene to own it, but I may think of some reason for that not to be the case later. So each renderable is added to an internal sim object that has a unique ID, and then this should have its own file format with nestable objects. So this should be traversed depth first to ensure proper parenting of sim objects. So depth first means if we have, let me open good old Paint here, and I guess I'll just use the pencil tool for now. That should be, yeah, that should be good. So basically what that's going to mean is we'll have, and that's really thin. Let me bulk that up a little bit. So basically what we're going to have is a scene hierarchy where we're going to have objects, right? So we'll have an object here, in it we'll have children objects, right? And we've already kind of seen a little bit of this when we run our game with the cubes, right? So this can have more children, right? And so on. And so each one of these will have an ID. So, you know, this one will be like 0. This one might be 1, 2. I'm writing this with a mouse, so I apologize for my handwriting. Right? Each one of these will have a unique ID. And when I say depth first, what I mean is we'll basically have some sort of file format where we will basically say, okay, what's the first child of this one? Let's set that up. And then what's the first child of this one? Well, it doesn't have any children, so let's go back up. What's the next child of this one? Okay, we'll set this up. What's the first child of this one? Set this up. Go back up here. Come down to the next child. Set that up. And then we're done because we have no more children, right? So breadth first would basically just be going across this way instead of down this way, right? So that's the difference there. And so that's how we're going to kind of enumerate our way through that. And just a reminder, if you guys have any questions about any of this, feel free to ask in chat. Let's see. Say scenes contain visibility information for culling, like portals or rooms. Where in the application would you slot that? Does the scene manage what it takes, what it submits for drawing? Does the renderer reject draw packets outside of the view, etc.? Okay, so this is kind of more or less what I was talking about when I was saying that we're going to start off with a basic scene, but the scene is going to be responsible for deciding what needs to be rendered. So if you think about it, there's no need for the renderer to know about parenting or any form of hierarchy, right? So parent-child relationship. Renderer doesn't need to know about that. It doesn't care. The renderer deals with nothing but world transforms, right? So it doesn't care about that. The renderer also doesn't care about visibility. Why? Because if it's not visible or shouldn't be visible, we shouldn't be passing it to the renderer. So the renderer should not know about that either. If something's being culled, then it should be handled before the renderer even gets it, right? So where we have portals or rooms, the scene is going to be responsible for calculating what is going to be visible through those things, right? So we're going to have, when we add those things, we'll also have to add methods to be able to cull that stuff out. Now, portals and rooms, there's a bunch of ways that we could implement that. You could use blocking volumes, and that's basically just like a square that exists in the scene that says, if the camera's looking at this thing, don't draw the stuff on the opposite side of it if you can't see it, right? So you could create rooms that way. We could also use constructive solid geometry, which is CSG. And that is what you've seen mostly in older games. I think Unreal actually still has it around though. It's where you can sort of use brushes to subtract and add into 3D space and sort of build objects that way in the game. That is something I would like to add at some point, but that kind of comes with its own set of things we'll have to work through. So, but in general, to answer your question, I think what you're saying is where would that stuff exist? And that is mostly going to be in the scene. The reason for that is there is also other stuff in the scene that none of the rest of the engine really needs to know about, except maybe some of the other systems, but things like oct trees to determine what is close versus what is far. There's going to be sort of all kinds of optimizations that we can put into the scene to help it manage that kind of stuff, right? And so if we have multiple scenes, each scene would sort of have its own management of that kind of stuff. I hope that makes sense. Let me know if that doesn't answer your question. Okay. Oh, TNT. Hey, what's going on? Welcome. Late to join. No worries. No worries. That's what the video on demand is for. And of course the archive on YouTube. So no worries. We're just sort of going through the plan of what we're going to be creating next. So we've just got a couple things up here that we need to make sure work and some work to be done. And then we are going to be adding scenes to the engine. And so basically what I did was I just sort of outlined some ideas on what our approach is going to be, and we're going to kind of try to follow this along as we implement it. So we're going to be implementing a non-ECS scene, which we actually just finished reviewing. And that is just like what it sounds like. It's not going to use an ECS. We're going to use known types and interact with it directly. And then we're also going to have an ECS type of scene, which is going to come sort of packaged with an entity component system to use with that scene. So both of these scene types are going to interact, or going to implement rather, a generic scene interface, and this is what the engine will see, nothing else, right? So all the optimizations, all of the scene management, all that stuff is all included within the individual scene itself. Okay. So the ECS scene, again, uses the generic scene interface. This works with entities which may have any number of components attached to them. Components will implement a generic interface, which will be added via generic calls to the scene to add these components. So you can kind of think of the components are going to be a wrapper for these known types, right? But they're also going to follow a generic interface so that we can add any number of different types of components, including custom components, to the scene, and the scene doesn't actually have to care about that type. So there are advantages to both, and there are disadvantages to both directions, and we're going to implement both of them to highlight those things. The main reason you'd want to use a non-ECS scene is because it's the simplest, and it's the quickest to get up and running, and not all games actually require the complexity of an ECS. ECS adds a lot of overhead that you might not necessarily need for a simpler project, and so we are not going to be enforcing the use of ECS in this engine. We are going to allow the user to pick one or the other. Okay, so components will house the renderable or pointers to them. All right, I already touched on that. So this is the plan, right? So I hope that makes sense. And let's actually go ahead and get started, right? So first thing on this list is to confirm that mesh unloading works. So that is the first thing we're going to tackle. So we have this sort of generic event game onload scene, which is a bit of a misnomer because we don't actually have a scene yet, but this is sort of what fires off a debug event to load some code in our application. So I'm going to create another binding for this. This is our game keybinds, right? So we have something bound to load scene, and now we're also going to have something bound to unload the scene. And I'm going to use debug2 for this, right? So otherwise these are exactly the same. If we come down here, will you be running any lives March 7th to 10th? No, I will not, because I'm actually not going to be in town. Roberto, why do I think that that's you? How hilarious would that be if I'm right on that? I don't know. I have a sense. Okay, so we have our load scene here. We're just going to add another binding, and I'm going to tie this to you and say unload scene. Now that we've added this here, we also have to make sure to unbind it when we reload. So let's see. Oh wait, actually, no we don't, because that is done automatically for us here. So we actually should be good. All right, so that is keybinds. We need to go to never. Yeah, that definitely tells me that's who you are. So the next thing we need to do is go to testbed main, and we have in here somewhere our registrations for the events, right? So here's the register, here's the unregister. We are currently registering debug 0 and 1 to game debug on event, and I'm just going to tie 2 to that as well. So we'll go ahead and use this. Oops. And I think we have 5 of these to use, so we still have a couple more. And these are just sort of temporary, right? We're eventually going to tie some UI to this, or maybe a command to load and unload levels once we get to that point. So this is just very temporary. And then game on debug event. So if we take a look here, our case for this is basically this is where we're actually loading our models, right? Right now we have a state that says whether or not the models are loaded, and we're loading the models, flipping that flag to true, and then actually loading the models, which probably, yeah, I guess we did this first because we don't want this loading to be kicked off twice, which is fine. So what I'm going to do is copy this guy and essentially do the opposite, right? So I'll change this to 2, and then we'll say if the models are loaded, which they are not by default. We'll say unloading models, and then we're going to take this flag flip and we're going to put it after what's going to become our unloads, right? And then this is going to be mesh unload. And I think all that requires is just the mesh. So we can get rid of this name and whoops. And that is already a pointer, so we should be good on that front. And this returns void, so we actually don't need this check at all. So we could just say, literally unload both of them. And yeah, in fact, what happened here? Why is that that should be this. Okay. Typing is a challenge for me tonight, apparently, folks. So we're going to do both the car and the sponsored mesh. So those should be both unloaded at that point. And I believe these are actually, are these zeroed out? Let me just quickly check to see where these things are. Right, so the car mesh is literally just a, it's the address of one of our meshes in here, right? So we can go ahead and keep that. One question I do have is the mesh unload. Does that actually zero the memory? Yes, it does. So we're actually good to go on that. So I'm curious to see if this is going to work because I actually don't know. So let's go ahead and build. And we'll run. All right, and then I'm going to load the scene. Right, so that's all loaded properly. And now I'm going to hit U to unload. And it looks like it worked. So let's see. Yeah, we're only drawing 3. So yeah, I think that worked. One test that I want to do on a fresh launch is I want to go ahead and grab the memory statistics. So it looks like we're sitting at about, you know what, I'm actually going to take a screenshot of this. Sorry if that freezes the screen for a second there, but I just want to get a screenshot of our current memory usage, right? And then I'm going to load and grab another one. So let me expand this up a little bit. I guess what I'm really interested in is these last few numbers here. Let's see. So our GPU local has gone way up, right? And remember, this is because we're not like compressing our data or anything yet. So all those textures and all that geometry takes up a crap ton of memory right now. So that's eventually something we're going to have to optimize. So I'm going to grab a screenshot of this as well. All right. And so now we can see on here that we have our sort of 999 number. Now what I'm interested in is to see if that number goes back down when we unload. So let's unload and hit the memory again. And yeah, our GPU locals drop back down to 278. So it is actually unloading all the stuff. It doesn't look like, though, doesn't look like it let go of our texture references, which I'm assuming is where all of this came from. Let me relaunch this one more time. That may not be true. That may just be our buffers taking all that space, because I think that's actually how much I allocated. So memory, yeah, 278. Okay, so yeah, so it looks like our unloading actually works. So yay, we can actually cross off the first item here on our list. So that is, let's see, do we have a strike through? I'll just use text color, that's fine. All right, so we're good there. Now this next one is not going to be so quick. So this one is going to be turning the lights into actual objects in the world. let me kill this. So we actually implemented lights quite some time ago. And our lights do not have any representation in C right now. They only are represented in our shaders, specifically under assets, shaders, and it is material shader frag, right, for our fragment shader. Let me, whoops, resize this. In fact, let me close this. We don't actually need all these terminals right now. So what we have is we have a couple of structs here that we've sort of defined. So we have our directional light, our point light, right? So these are the structures. And then we have a directional light that's been defined here. And this is the direction of the directional light and the color of the directional light, right? And then we have 2 point lights. So we have these guys here. We have P light 0 and P light 1. And likewise, this has position, color, constant, linear, and quadratic, right? And so these have been hard-coded into the shader, which was fine for us to kind of get things up and running, but we need to actually handle this to-do. Yeah, 11 months ago, right? So it's been a while since we've messed with any of this, and this is something that's been on my to-do list for quite a while now. So I think it's about time we go ahead and handle it. Okay. So what I'm going to do to handle this is I am thinking, so we have our local uniform object. We have local, instance, and global, right? And so our local is basically just going to take the diffuse color and shininess, this is kind of our material properties, which we probably should be using a struct for this too, so we may actually wind up changing that up as well. But should I include it on the local? Or should I use instance? I'm thinking that we should probably take a look at the config to see how we actually want to handle this. So for each material, we are tossing through these samples, right? These samplers, one for each one of these textures. I'm sorry, this color, and then one for each one of these textures. And then we're doing shininess. So this is at the material level, right? And then the individual object level, or the local, if you will, has the model matrix. So, oh, did we actually misname that? We might have. I think we actually misnamed that in our shader. Yeah, we're calling this local uniform object, and that's actually not technically correct. That should be instance, right? Because it's material instance, not local. So that's why I got confused for a second, because that's actually named wrong. So here's the scope, right? So we have the global scope, which is for things like our projection view, ambient color, and view position. And I'm actually thinking, this is probably where I'm going to wind up putting the lighting information. There are going to be limitations to doing it this way, and it is going to have to be refactored, but I think that's going to be what we're going to do for now to get it to work. Although, yeah, because the only other place that would make sense to put this stuff would be at the model level, or the local level, right? But we're limited on space there, and these structures are actually pretty big, right? So, we can't be passing multiples of data this large within our local scope, because we're only really guaranteed 128 bytes, right? So I guess it does unfortunately make sense to have to put it at the global level. I'm not really too happy about that, because we only, maybe I should just do it at the instance level. Okay, so here's why I'm debating this. So at the global level, we only apply this once, basically, per shader per frame. And that's because the projection matrix doesn't change, the view matrix doesn't change, the ambient color of the scene doesn't change, and obviously the view position doesn't change, right? That's not going to change within the same frame. Same thing with the mode. The instance level stuff changes per material, which there may be several instances of the material scattered throughout the world, not necessarily right next to each other. And so the issue with putting the lights there at that level is the lights might have to actually change per instance, per material instance. But I think that might be something we have to just kind of accept for now, because doing them at the global level really doesn't make sense, because we really only want to update that once per frame. This is technically supposed to be updated once per material, so we might wind up having to do multiple updates per material, which isn't great, but we might not have a choice. Because this isn't an option. So I guess that's where I'm going to put them. All right. So the next thing we have to consider is we actually only have certain types available for this, right? So the uniform, first thing we do is say type, and it's either a sampler, like a U32, a vector 4, etc., etc. And these individual lights, here, are several of those things combined, right? We don't have any way in our configuration to talk about structs. So I'm thinking we might actually need to create a new type called struct that maybe takes the size after it, where we can define that. Which is not ideal either, but I can't think of another way around it for right now. So I guess that's probably the first thing we need to do, is figure out how we want to do this. So let's say for directional light, for example, we have a vector 3, which is 3 floats, so that's going to be 12, and then we have a vector 4, which is 16, right? So the first thing that we're going to have to do is add here a structure. Where are we going to add it? I guess we can put it right here towards the end of this. We'll say uniform. We'll call it, we'll call it str. Maybe we'll say struct. And then we'll do, what did I say? It was, what did I say that was? It was 12 and 16? Yeah, 12 and 16. So that's going to be, what, 28? So that would actually be struct 28. It's going to be at the instance level, so 1. And then we're going to call it dirlight, right? So we're going to stick with this same name here. So we'll call it dirlight. And then the next one is going to be another struct. And this one is going to be, let's see, so we have 28 again, 29, 30, 31. I wonder if I should just pad that out and make it 32. Heck with it. Oh wait, what am I talking about? These are 4 apiece, not 1 apiece. It's been a long day. So we have 28, and then we have, that's 32, and then 36, and then 40. So that's going to be 40. And we'll call this, I think it was P-Light 0. And we'll do the same thing. We'll call it P-Light 1. Now, I suppose we could technically turn this into one giant data structure and just kind of combine all these bytes together. But I don't really like that either. So this is what I'm going to roll with for right now. I'm not completely sold on this yet, but I think it's the most flexible way to actually handle this. So if you guys actually happen to think of something different or better than this, feel free to chime in. All right. So the next thing is, I guess I will go into our system and implement this. So I'm actually just going to copy these, and then I'm just going to do a search for SAMP because I know that's will take us right where we need to go. All right, so here is where we are actually loading in our uniforms, right? So let's see, strings equal I, samp or sampler. So we're basically just going to add another case in here. So we'll say else if, oops, go away quotation mark. All right, and we're basically just going to pick this apart, right? So here we're doing a strings equal I on field 0, and we're not gonna necessarily be able to do that as is. So string, let's see. I guess we should probably do I actually have a equal I, n equal I? I do. So we can actually say the max number of characters to be compared, right? So we can use fields 0, and then we want to compare to struct, right? And whoops, and that is going to be a length of 6, right? So if the strings, the first 6 characters of the string equals struct, then we're going to go ahead and process this. Now, the next thing we'll have to do is, Roberto, you've got nothing. Okay. That's fine. That's fine. I got nothing either. I'm just winging this. You know, this is part of the process here, is just kind of showing you guys my thought process as I go through developing this stuff. So what I'll need to do is grab the next several characters of the string, right? So I'm actually going to have to go ahead and grab the length of the string, and that's going to be fields 0. And then U32, actually we should probably check this, right? So if length is less than or equal to 6, then we have a problem, right? So k error shader loader load invalid struct uniform size is missing. And I guess, do we want to default that? I feel like that's kind of dumb. So I think we do return false if this fails to load. I feel like that is enough of a bug. We should probably abort out of loading this. At least for now. So what does this do? So we're just defaulting here, but I don't really want to do that for this. So shader load aborted. Okay, so obviously this means we can boot out, right? Otherwise, u32 diff equals length minus 6. And then the diff is basically how many characters we actually are going to wind up parsing to a string. So string mid, the destination, let's go ahead and create a character array here called struct size. And we'll just set that to something stupid like 100 characters, right? We're never going to need anything. Actually, that's way too big. 32 characters should be enough, right? And we're just going to zero out the whole thing. So string mid, we're going to go into struct size as our destination. Our source string is going to be fields sub-0, and our start is going to be the 7th position, which is going to be index 6. And then the length is -0, then it goes to the end of the string. So I'm going to go ahead and just say 0, actually. We might not even need the diff, right? I think we can actually just get it from that. And then string, let's see, do we have a to u32? And that's going to be struct size. And we're going to u32. You know what, let's call this struct size string. And call this struct size. Right, and then we'll pass the address of struct size here. And we should probably check to make sure that parses correctly. If that does not parse correctly, then we need to throw an error. Unable to parse struct uniform size. Shader load aborted. Right, and again, we'll return false. I'm not really worried about like the fallout of all this stuff, because if we do this, it's a pretty big error, and we shouldn't really continue running correctly anyways. Yeah, I was wondering when somebody was going to notice that TNT. So yeah, there's just rewards and challenges section that you can earn coffees. So yeah, there's all kinds of things that you can actually redeem. So the longer you watch the stream, the more options, the more coffees you'll get. And you can turn those in or redeem those for various rewards. So if you guys ever have any ideas of things I could add to that, feel free. But yeah, just definitely have a look through those. You have enough coffees to add a command. All right, well, that's pretty cool. I actually don't know how that feature works. I've not used it myself, so that's pretty cool. You did redeem a hydrate, though, so I will go ahead and do that. Thank you for that. Okay. Yeah, there's also, there are stretch. Stretch. It's probably good for me to do this anyways every once in a while. Oh, yeah, I haven't done that in a while, I can tell. Imposter check. Yep, fair enough. All right. So, thank you for those redeems. Cool. All right. Yeah, and on occasion I'll probably use my standing desk too, so the posture check might be a good idea there too. All right. Cool. So where was I? So if we parse this correctly, then we should be able to come down here and say uniform type. Probably going to need to create a new one of those. But the size is going to be the struct size, right? So let me see where all of this is used. I don't think the type matters really beyond like sampler. Right, I don't think for most of these the type actually matters. Yeah, not really. Lack, thank you so much for the follow. Appreciate it. All right. So with that, I guess I can actually, I'll just add a new one. I could use custom. I don't think this is actually, yeah, I'll use custom actually. Because that is a custom sampler type. All right. Or custom uniform type rather. So this is basically what we're parsing here. We will have already gotten the name from that. I think this should be good enough, assuming that this works the way that I think it does. It's been a while since I wrote that. All right. So let me just check something real quick. All right. So we have that. We have the ability to read that anyways. So I'm going to go through actually and I'm just going to build real quick and put a breakpoint here just so I can make sure that this actually works. This is actually going to be a breaking change. It's not actually going to run now. Right. See all this? Uniform type must be. Oh, I see why. Whoops. This should be else if, not just an if. Not sure how I missed that. All right. So let's go ahead and put a breakpoint here, actually. Hot Rush Games, thank you so much for the follow. I appreciate that. All right. So our length is 8, which we expected because our string is struct 28. So we should be able to get our zeroed out string. There we go. We will string mid that from the 6th position, or I should say the 7th position to the end of the string. So that should just give us the, well, it should give us the 28, but it did not for some reason. So I need to debug that. Length equals 0, return. Perfect. Okay. I thought that I had. Didn't it say in the tooltip that if the length was 0, just go to the end of the string? If it's greater than 0, all right. I guess I'll just pass a negative value then. But I think that means that my comment is wrong. If length is negative or 0, goes to the end of the string. Yep. Okay. So that threw me off. So I'll fix that because it should only be negative. Okay. So this needs to be a -1. What is a RAID? So a RAID is basically when a streamer is tying up a stream. Oh, you know what? I didn't even realize there was ads going. I completely missed that. All right, so for those of you that missed the last couple things I said because there were ads running and I didn't see it run. So I went into KString and fixed this because this said if length is negative or 0, it goes to the end of the string, and that was actually wrong because looking at the code, if length is 0, it just boots out, right? It has to be negative in order to go to the end of the string. So I changed that. And then to answer TNT's question, what is a RAID? So when streamers are finishing up their stream, what they will do is they can pick another streamer that they follow, and they can do what's called a RAID. And what that does is it allows all of the current viewers of the current stream to transfer over to somebody else's stream when this current stream ends. It's a way that we can all sort of support one another by, exposing people to new streams and stuff like that. And so it is something that you can opt out of, or you could always close out of it afterwards, of course. But that's basically what a RAID is. And so if you were to determine or to try to determine the direction of that RAID through a redeem here, which I think is all the way at the bottom, guide the RAID, then that would mean that you have a say of over who gets raided. So I hope that makes sense. All right. So let us see now if we actually parse correctly. Yeah, no problem. All right, so we got the string mid, and we have 28, and it's 0 terminated. So that works as we expect. And then we have string to U32. So we're going to pass this as the string. We should get the number 28 here. And we do. So now we actually have that parsed as a number. We can use it, which of course means that we can set the uniform type and size appropriately. So that is awesome. That is working as expected. All right. So there's that. Now the only other thing is going to be the material shader is going to have to now fill that in. So I think what we're going to do is we're going to shift our hard-codedness out of our shader and shift that temporarily to the material manager. So that way we can at least see that the data is going from the C side into our shader code. So to do that, I'm going to have to go back to our shader here. And I'm actually just going to copy these guys, comment them out, go into our material. Actually, is it the material system that even does this? Where did I actually put that? So we have initialize. I think this just manages the materials of cells, not actually. Oh, acquire from config. Yeah, so we do need to actually do some work in here as well. Release, apply. Okay, so yeah, this does apply all the stuff. Okay, so this is actually where we're going to be doing our work. So, oh, thank you for the bit, Roberto. I appreciate that. The 1 bit, I appreciate that. That's actually the first bit I've gotten, so I appreciate that. Thank you, sir. All right. So I guess we can start here with the apply. Oh, you know what? No, I can't start with the apply. I've got to start with getting the actual uniform. So let's see. If we save off locations for known types. So this is material shader. We do not want to do this in the UI shader. Okay, so I forgot that we had this actual known code in here. We probably need to separate out the UI shader, honestly, to work a little bit different. But for right now, this is how I'm going to work. Don't spend them all in one. I don't know what a bit is, but you deserve it. Bits are actually, you can think of it as sort of a like a donation. It's kind of like a tip, if you will, like a monetary tip. So every bit sort of equates to a certain amount of dollars/cents. And then I get a percentage of that from Twitch, right? I think when all is said and done, I want to say I get 70% of that, I think. If I had money, I would sure give multiple bits to you. Yeah, that's cool. I appreciate them, but they're not. Yeah, you gave me like 0.001 cents. Yeah, it's probably like, I actually don't know what the conversion rate is. It's probably like a cent, literally. Is it OS Mudge or is it O Smudge? Thank you so much for the Prime. I appreciate that. All right, cool. So, oh, there's another bit. Thank you for the second bit, Roberto. I appreciate that. So let's go ahead and I'm just going to paste these in here. This is obviously not C++ code, but this just to kind of give me the names, right? And I'm going to jump back to the shader and grab. I'm going to paste the copy here again, but I'm going to remove the data from it, right? So we are going to feed this in, right? We're just going to define them as variables for right now, all right? And this is going to be, let's see, so we have our structures up there. And we will put this in. I guess I could put this in. Do I want to pass it through or do I want to just load it? Let's do them here, I guess, is probably going to be the way to do this. So our samplers come in on set 1, binding 1. We are likely going to do something similar, except these are each going to have their own binding. Right, so this is going to be, I think this is going to wind up being binding 2, 3, and 4 off of set 1. Let's see. At this point, we're just costing Travis money by not letting him code. No, it's fine. Here's the problem. I can only give 1 bit or 100, but I bought 95. You can actually spam the chat with like multiple bits if you wanted to. So yeah, exactly. You could like you can send I think actually, can't you enter a custom amount? I could have swore you could. I can't see it because I can't do it on my own channel, but I think you can. Can't you do like 5 at a time? Something like that? Maybe not. You might have to put a bunch of 1s in there. Hashtag following. Thank you, sir. Appreciate it. All right. I think this is going to be correct. I'm not 100% sold on it yet, but I think that is what we're going to want. Okay. 93 bits. Awesome. Thank you for the 93 bits. Appreciate it. Okay. So all of these things I believe should work as normal. We shouldn't have to change any of this code here. We're simply changing the way that it actually comes in. So back in our material system, let's go ahead and update that. So we're going to need 3 more locations, 1 for Durlight, 1 forPlight 0, and 1 forPlight 1. So I'm just going to copy this real quick and go to material locations, material shader uniform locations, and we're going to add some U16s here. And we also need one U16, right? And now we should be able to build those in to our logic here. So we'll come down here, and I'm just going to copy pasta this, right? And instead of render mode, it's going to be dirlight, and I'm going to copy that because that's the name of it, right? And so all we're doing here is just grabbing uniform indexes for our various properties here. So let's see, we had point light, which is p light 1, 0 and 1 rather. So there we go. So there's our new ones. And let's see, so that's that. I'm going to grab this because I'm going to need it elsewhere. So there's our new fields there. And basically when we go to apply, so this is our global application. This is the instance application, which is where we're going to put it for now. I'm going to paste this just so I don't lose track of what data is here. And so this is where we're actually applying this, the data, right? And so I think I'm going to go ahead and hard code this from now. And what we're going to do is we're going to actually have to have some way to pass in light data to here. But for right now, or I should say pass it in or call out to retrieve it somehow. I'm not totally convinced this is going to be the way to do it, but this is me trying something out to see how it works. Lols, you're going crazy with the emotes in there. All right. So the first thing we're actually going to need to do is actually create these structures. So I'm going to cheat a little bit and copy that from the GLSL because it's dang close to what we need. So we need this. And in our material system, I'm going to do a very temporary hacky thing. To do hack temporary lighting structures. To do hack end. And I'm going to put these here. I'll do a type def. So that we don't have to type struct every single time. Point light. And because we name these vec3 and vec4, which matches up with the GLSL types, we actually don't have to rename any of this, which is awesome. So we just kind of get that for free, which means that I guess I can just create these statically for now. Right, and this, of course, is another hack. Testing, or actually I should say, moving lighting code to CPU. So we'll do directional dirlight. Actually, I'm going to copy this whole block here because I think I can just do. I think I can just do that, and that should work. The only thing is, instead of constructors, I'm going to have to change this to a cast. Add f's to these to make them floats, not doubles. Change this to a cast. And change these to f's so they're floats, not doubles. And yeah, okay. Next we'll change that to static. Okay, so that just means that we'll stand that up once and then just reuse it repeatedly after that. We're going to do the same thing for these two guys. So actually, I'm just going to uncomment these. Get rid of this and this and this. And we'll say static in front of all these guys. Oh, I somehow got rid of the name of that one. All right. And then these will obviously just have to be changed to casts. Sorry, I paid a coffee for it, so I wanted to get my coffee's worth. I get it. Somebody found the somebody might have found the secret coffee command, right? Chat has drank a total of 4 cups of coffee. So if you just type in coffee, there is a counter that runs. Little secret there. I haven't actually put that out there yet, but every time it detects the word coffee, it says chat has drank another cup of coffee. All right, so change these to floats. And you know what? Are all these properties basically the same except, yeah, except the color, I think. And the position. Screw it. I'll just do it the hard way. It's fine. I was going to cheat and copy pasta it, but I'm more likely to screw something up if I do that. Change these all to Fs. Right. So we have just some temporary data there. And now I will come down here and apply it. So the index we're going to use for this is going to be the dirlight. And we are going to pass it the address of dirlight as the data. And then we're going to do the same thing withplight1. Oops, plight0 and plight1 rather. Right? And that should actually be all that's required for that to work. I'm somehow not convinced this is all I need to do, but I'm going to go ahead and build it. Somebody reads their release notes, I guess. All right. When I run a task, I'm also going to post build. So we're going to rebuild our shaders. Yeah, I had a feeling I screwed something up there. Let's see. Let's expand this up a little bit. I have a feeling here the non-opaque uniforms outside a block. Not allowed when using GLSL for Vulkan. Non-opaque uniforms outside a block. Let me think about what that actually means. Does it have something to do with this? We have our structures up there. You know what? Binding requires a block or sample image or atomic counter image. Binding. Was it maybe bleating about this? I'm going to Google this and see what it means. All right. Let's see. Oh. It literally has to be... Let me see here. Oh, I should probably show you guys what I'm actually reading. Uniform the struct. Oh, do I have to... Oh, I probably have to declare it there. Instead of up here. Well, that seems kind of dirty. What was that again? The struct. So I do need that to be forward declared, but then it's saying to put it like this and just have the members. What? Why would I have to declare that twice like that? That seems kind of strange. So is it literally saying that I have to... How do I reference it by name then? That doesn't make any sense. That doesn't seem right. Let's see. It's probably going to be something stupid I did in the syntax, I'm sure of it. Could have swore I did this with OpenGL a bunch, though. Exactly like I have it. But maybe Vulkan doesn't like that for some reason. See if I can find an example of what I'm looking for. Nope. I don't know what they mean by non-opaque uniform. What was the other error I got? Maybe I'll find something based off of that. Binding requires. RIP. Oh, dude. This is half of development, is like running into something stupid and then Googling it. Like, why doesn't it work? No, that's not what I want. Stack Overflow betrays me again. All right, let me try the way that this guy did it. This seems kind of dumb, but I'm just going to copy this example here into my code and see how I might refactor this. to get that to work. So I had everything up till here correct. So, yep, uniform this. And then I guess I can't name it. Is that the issue? Or is that the actual structure definition, which is kind of what it looks like to me. So maybe it wants this. If that's it, that's really kind of dumb. So let's comment this one out and see if we get any less errors on that one. Wow, it just aborted and says see logs. Okay, what logs, you dingus? What logs? Maybe because I had struck there. I don't want to run this. Stop it. I meant to hit run task. Useless application of layout qualifier. Well, that's all the way down here. It is being a bananas. It truly is being a bananas. Yes, you're absolutely right. Let's see. Unexpected left brace. This is literally what this person was suggesting. Of course, this is Reddit, so who knows how accurate that is. Oh, wait, here we go. We actually have... Actually, this works. So it is declared up front. Did I remove that? Yeah, so that's there. And then uniform of the block. Oh. Oh. Okay. So what this actually wants is, let's see. Layout, set binding, uniform, the struct type, which is still that. Oh wait, no. That is, what? That is really weird syntax. Okay. So this is actually the name of it. So dir light. And then within that we have light. All right, ads. right. Back. Cool. So I am just going through here and trying to convert this to the other struct type here. Because this apparently acts completely different than what OpenGL did, which hasn't really been too much of an issue up to this point, but is now. So let me try building this. Okay. I may actually have to, instead of running that, I may wind up having to actually run this manually, which is unfortunate, but for some reason the logs are not actually giving me the error message. So let's have a look at process shaders. I have a feeling it has something to do with this. So let me actually look this up real quick while I'm at it. See error handling. Let's see, is there anything in here for a reason? Does this give us any sort of exit status or logs or anything? No, it really doesn't. All right, I'm just going to run this manually then. So open up a terminal. And I'm just going to grab this. And go to the Kohi directory. Oh. And I guess I'll go into CD assets. Shaders. Okay. DLSLC. Let me make sure. Yeah, of course not. Okay. So I'm going to have to build this out too. Vulkan SDK. GLSLC. Actually, it might be bin. GLSLC. Just want forward slashes. What is in Vulkan SDK? Nothing. Really? Okay. Vulkan SDK. Bin. GLSLC. Do it this way then, stubborn bananas. All right. Stage equals frag. And then, let's see, the next thing is going to be the bin folder. So I need the third input, which is going to be the stage. The next one is going to be this. And I think the last one is going to be the same thing. just the out file name, which I think is just going to be almost the same thing. So -o, and this will be SPV. Okay. Oh, it's because I'm in the folder already. So this actually just needs to be this. Wow, and that gave me no output whatsoever. All right. I love when tools just fail silently. That's my favorite thing. Double dash help. Where is the... We have a verbose setting here. Let's see. Oh, okay, so not... Options. Include directory. I'm going to leave now, so everyone have a great day or night, depending on location. All right, TNT, I'll see you. See you later. Thanks so much for joining in. Hopefully we'll have this sorted soon. Let's see. So we are outputting that. Specifying a target version. Yeah, I don't see anything here. Did it actually create the file is the question. So the file is there. Built-in material shader frag SPV. I'm going to remove that file and run this again. Yeah, it's not creating it, but it's not giving me any errors either. So whatever we're doing is like crashing it, which is awesome. Which explains kind of why we're not getting any error output as well. So that seems fine. That's good. Nothing like crashing the shader compiler on the fly. All right. So we have point lights. This looks exactly. I mean, this looks correct to me. If I comment these out and run this, let me just make sure it's not something. Oh, it's something else maybe. So what else? What else could it be? What all have we modified, actually? I suppose that's a fair question. So we just commented those out and added this, and somehow that's causing it not to build. Like actually, literally all we've done is like remove the hard-coded things, and it's causing it not to, it's causing it to actually crash, which is absolutely insane. Well, I think I'm going to have to probably do a little bit of research on how this is supposed to work, because it seems like I am misunderstanding how this should work, syntactically anyways. So I guess let me try a couple more things. It's really bizarre that that doesn't... Okay, but if I re-enable these and... Oh, it could be because these are actually being used in code. Okay. Directional light, directional light. Yeah, so this is actually being used here. So maybe if I update that, maybe that's the issue, right? It's got all these undefined references sort of in code. I'll bet that's probably what's causing it. Although why it's not giving us that error feedback, I'm not really sure. If I re-enable both of these sets and post build. Yeah, okay, so now we're actually getting an error. That's really interesting that it seems to fail if these are commented out. All right. Block name cannot redefine a non-block name. All right, I'm pretty sure I had the syntax correct. Am I... Wait a second. So these are the attributes as they come through in the vertex shader. This is the global uniform object. We have a DTO, this is not a local uniform object, I don't think. This is, oh wait, it is, isn't it? What is the shader config? Yeah, the shininess. I'm overcomplicating this, I think. This stuff is actually supposed to be in here, actually, I think. Because the shader... not shader system. Material system. This has shininess right here. Yeah, okay. Yeah, I completely overcomplicated this. Sweet. Okay, so this is all rubbish. We don't need any of that, actually. It turns out it was not it being a bananas, but me being a bananas. So these should be in here. So directional light and our point lights should be there, right? Which means these need to be moved further up so that they are declared before that, right? And these guys go away. And anywhere that I use directional light, I now need to call object UBO directional light. So that's going to be this. And thenplight 0 is going to be the same thing. So it's going to be just this, and I think that. That's what I meant. I knew. I always knew. Of course you did. You are no birdo. All right, post build. And it builds. All right. Well, it kind of builds. It's like taking forever to finish doing the thing. Why are you taking so long to finish the thing? Let's just do that again, because it's taking forever to finish. You know what? If it's generated it, that's fine. I'm going to kill it. I don't know why that happens on Windows sometimes. All right, let's run this. See how far off I am. All right, well, we got some interesting results. Some very, very interesting results. That is definitely not correct whatsoever. So it looks like I'm guessing we've got like a data alignment issue or something. Because if I load this, we've got all kinds of interesting things happening with our uniforms here. So I am actually wondering if this is due to us using a funky layout in our uniforms. It does look pretty cool, actually. It ain't right, but it looks cool. Oh, interesting. Our normal view works correctly, but our lit view doesn't. Okay, that's actually somewhat telling. Did I calculate something wrong? So, the material shader config here. It's 28, 40, and 40. Are one of those wrong, maybe? So this should be 28, right? And then we have 12. Blessed. Thank you for the follow. Appreciate that. Let's see. We have 28 plus another 4 for a float, plus another 4, plus another 4. That is 40. So these are correct. Oh. But we do have an alignment issue here. So I'll bet if we move shininess to the end, I'll bet that fixes it. Post build. OJ Mr. 7, thank you so much for the follow. I appreciate it. Let's run this. Nope, that wasn't it. So we're still got some weird bananery going on here. And it looks like our yet the normals view still renders correctly, which is quite strange. So the only thing that I can think of then, maybe we need to pad this somehow. I don't think this should be necessary, but maybe it is. Let's try adding that to the shader config as well. Let's see, so we have 28. Oh, you know what? These are out of order. Wait, no, shininess was at the end here. So that was actually out of order before. It's not now. Okay. So we'll add a new one here. We'll call this a vec3, put in some padding, post build the shader. See if that helps. That did not help. I'll drag this down here so you guys can see. So we've got some sort of, this feels like a data alignment issue to me. It really, really does. So we've got our directional light structure here, our positional. Man, maybe this needs to be padded out. I can't imagine that's the case. But maybe it does. So we already switched these over to use object UBO. Do we have any more instances of use lights? No, we don't. So this should be the only reference I have to change is here for that. The reason this is correct is because it's not using any of those. Oh, you said the mic messed up? Can you not hear me? Can you hear me? Better for you now. Okay. I wonder what happened. I thought I heard something in my headphones for a second. Okay. All right. So the thing that I'm thinking is generally with a lot of these types of data, they have to be aligned to like 16 bytes. And so I'm just wondering if there's an issue with that in here somewhere. So our directional light maybe needs I thought this was really only true for attributes, but I might be wrong. I'm just trying to square these out a little bit. So we have a total of 8 floats here. We have a total of, so that's 8 floats. This is 10 floats. Maybe we need that. And then this is also padded out correctly, I think. So I do not understand why this task hangs every single time too. That is definitely, let me reload the window. I don't think that's going to do it, but run task, post build. That's still hanging. Oh wait, did that complete? Am I just being impatient? Yeah, okay, I guess I was. All right, let's run this. Dang, okay. So still to no avail. We are still not right. Okay, so let me undo all these padding changes because I don't think that's actually it. That was just me trying something, but I don't really think that's the problem. I also need to go into the shader config and remove padding. I really don't think that's the issue. Our code should actually be padding this structure out to what we actually need it to be anyway. So we should be actually fine. P-light 0, P-light 1. Post build. All right. I still feel like this is a data alignment issue. All right, well, unfortunately, we are basically out of time for today because I actually need to get up in the morning and work. You know, that's kind of important. So 11 o'clock is usually where I call the stream, so I'm going to go ahead and call it here. We did make some progress because we are actually seeing some of this stuff come through. I have a feeling it's just the data is just not transferring over correctly. So I've got to figure out why that is and try to fix that because I don't know exactly where it's falling apart. We have these things all being passed through here. What I'm pretty sure is correct. So I'm not sure at this point why it's failing. So I'll do some thinking about it. We'll solve it on the next stream. And then, yeah, that's pretty much going to be that. So let's go ahead and see if there is a channel to raid. I'm going to raid Team Vosh. I raided that channel yesterday. So that's a two-person team. They're writing an MMO on their own from scratch. And right now, I think they're still in the research phases of some of the networking aspects of it, but they actually do have some decent progress being made on that. So I'm going to go ahead and raid that channel just to support that because I think it's a really cool project. And so with that, thank you guys so much for the support. And I will actually see you guys on the next stream, which is probably going to be next week. I'm thinking I might have some time on this weekend, but I'm not 100% sure. So anyway, thank you guys. I'll catch you later.
With TLS encryption. Oh, read that page? Okay. Hey, Travis. Thanks for the raid, Travis. How was your stream? Yeah, we're doing good. I finished the A Cloud Guru courses, and we're moving on. We're getting closer and closer to what I'm here to do.